Hello, this is session 4 of Unit 6, and this session is about percentage of potassium trioxoiodate 5 in an iodated salt. Let's look at our objective. By the end of this session, you should be able to determine the percentage of potassium trioxoiodate 5 KiO3 in an iodated salt. Okay, so let's look at this problem. Iodated salt, sodium chloride with traces of KiO3, that is potassium trioxoiodate 5, is known to prevent a disease known as goiter. The amount of potassium iodate in an iodated salt can be determined by treating a known mass of the salt with acidified potassium iodide, and the iodine liberated is titrated with aqueous sodium disulfate. A is a solution obtained by treating 250 grams of iodated salt with acidified potassium iodide, and the solution made up to 1 dm cubed. B is 0.10 mol per dm cubed sodium disulfate. This is an instruction, but let's look at two equations that we're going to need. This is one, and then this is the other. Okay, so here we have the iodate ion reacting with iodide, and this protons to produce the water and iodine. The iodine produced here then reacts with the disulfate ion to produce the tetraazothionate ion and then the iodide. How or what will be our movement? Our movement will be from this disulfate ion to this iodine, because this iodine is what was produced in this first equation over here. Then we can now go to this side to find information, or per the questions asked, we can find for either this or that. So I hope you get the direction, because it's the disulfate that we've been given its concentration, and it will be convenient to start from there. We have to find the concentration of iodine in A, that is solution A, in mol per dm cubed. We have to find the amount of the potassium iodate, and then the mass of potassium iodate, and percentage. Okay, we've been given the average volume of B to be 20.00 cubic centimeters. Let's make progress. Okay, so we start from the disulfate by interpreting its concentration. So if 1000 contains 0.1 mole, then 20 cubic centimeters will contain 20 times 0.1 divided by 1000. That gives us 0.002 moles. So this is the moles of the disulfate in the 20 cubic centimeters that was used for the titration, and that is the moles that reacted with the iodine. Okay, so we now need this equation to find the corresponding moles of the iodine. From this equation, 2 moles of the disulfate ion reacted with 1 mole of the iodine, and so if 2 is equal to 1, then 0.002 is equal to 1 over 2 times 0.002 moles of the iodine, and that gives us this number of moles. Okay, but this number of moles is only contained in the 25 cubic centimeters. And you should also note that the thiosulfate reacted with all the iodine produced in solution A. So once we have done this and we have this number of moles, we can use this moles this moles in the 25 cubic centimeters. We can just convert or work it out into mole per decimeters cubed, and that gives us the concentration of iodine in A. Okay, so if this 0.001 moles is contained in the 25 cubic centimeters, then 1000 will contain how many moles? It will contain 1000 times 0.001 moles divided by 1000. That gives us 0.04 moles per cubic decimeters of iodine. So this is the amount concentration of iodine in solution A. And so we are done with this part, that is concentration of the iodine in A. Okay, so we need to find the moles of the iodate ion. But to do that, since there is a relation between the iodate ion and the iodine, we can go to the iodine, convert its concentration into moles, so that we'll use that relation to find the moles of the iodate ion. We have found the concentration of the iodine to be 0.04 moles per cubic decimeters. And the solution was prepared and made up to 1 dm cube. So we can use that volume to work this out to get the number of moles. And here we are using this relation, amount is equal to concentration times volume. So knowing this number of moles, we now go to the equation of reaction. This is the other equation is given in the question. Now from this equation, we have 3 moles of iodine produced from 1 mole of the iodate ion. So the relation in terms of mole is 3:1. 3 moles of iodine will be produced from 1 mole of the iodate ion. So if 3 is equal to 1, then 0.04 is equal to what? It will be 1/3 times 0.04 moles of the iodate ion, and that gives us 0.0133 moles. So this is the number of moles of the iodate ion in the solution, that is the solution A. Alright, so let's make progress. We know this number of moles, and so the rest becomes easier. Now using this relation, amount is equal to mass over molar mass, we find the mass. And so we know the moles. The molar mass we can calculate from the atomic or the relative atomic masses, and that gives us 214 grams per mole. So making mass the subject, we have mass is equal to amount times molar mass. The amount is what we found to be 0.0133, and the molar mass is what we have here. So that gives us a mass of 2.85 grams. The next question is to find the percentage of potassium iodate in the solution. We know the mass of the potassium iodate, and in the question we have the total mass that was weighed and used in the preparation. It was 250 grams. So out of that 250 grams, it is just 2.85, that is potassium iodate. And so we can divide the mass of the potassium iodate by the total mass and multiply by 100, and that is going to give us 1.14%. So this is the percentage of potassium iodate in the salt or in the solution that was prepared. And we are ending the session with this self-assessment question. Please try to solve it. We will meet again in the next session.